Okay, on a really simple level, when you're adding or subtracting, you have to have a common denominator. Okay, so you need a lowest common denominator, or not even the lowest one, just a common denominator. Okay, so you all know that from juniors here, we're hoping. So see a half minus a third. What would we have to have here? 6. So you go 3 above and below, and then you go 2 above and below, and you do the same thing with algebra fractions as well, as we've seen in the last exercise. That's for addition and subtraction only. Now, for multiplication, 4 sevens multiplied by 3 halves. It's very simple. It's top by top, bottom by bottom, every time. Everybody cool with that? Okay, so what would be the answer of that last one? 12 over 14. Anything any number that could come out there? 6 over 7. Is that cool, you guys? Anything too crazy so far? No. Now, there is something here as well that you might not be aware of. I can also chop it down to size before I multiply it. So, example, 2 divides into 4 how many times? Twice. Anything on the bottom can divide into anything on the top, provided it's multiplication. So see the way that's directly into 6 over 7 now? So you're allowed to do that as well for multiplication, just to bear that in mind. We on board? Right. Next thing, division. Division can be written 2 ways. Sometimes they like to stack them to make them look really difficult. So I'll give you an example. 3 halves divided by 9 over 7. Okay. Now, I know that looks really difficult, but here's what it actually looks like. 3 halves divided by 9 sevens. Now, does anybody remember what you did at juniors there to make this work? Grab the division sign and turn it upside down. So what you get? 3 halves multiplied by 7 over 9. And the answer would be simply 21 over, which is 7 over. Flip what's behind the division sign. Flip the 9 over 7 into 7 over 9 and multiply. Flip the part that's behind the division sign. Okay, give me a minute. Okay. I need something that I can relate to real life problems. All right, give me a second. All right, got it. All right. Yeah, that's what it is. Yeah. No, it's not. That's like. All right. So lads, you're at pizza. You're at a spot for pizza party, right? Sounds like a great old time. Now, lads, uh, you divide your pizzas into sixths. So I'm essentially saying just 6 slices per pizza. Is that cool with you guys? Is that all right? I'm only doing this once. I'm only doing this once. Right? You have 6 slices per pizza. All right. Now, so it's 2. Now, what I'm asking you to do is divide that by 1/6 of a pizza. 2 full pizzas divided by a sixth of a pizza. How many slices would you get if you're using a sixth of a pizza? You get 12, don't you? So what I do here is I take the second fraction and I turn it upside down. So what you get? All right. And 2 multiplied by 6, 12. If I flip the first fraction, I would have only got 3. So in general, when you're dividing, you only ever flip the second fraction, not the first one. And there's clear evidence. Dividing pizzas into sixths, you get 12 slices clearly. Is that all right? The one on the right, the one that's behind the division sign, turn it upside down. Yes. Yes, to 9 over 7. Is a sixth equal to 6? They don't have to be equal. The procedure is when you're dividing by fractions, get the second fraction, turn it upside down, multiply. That's all you need to know. And I proved it using pizza slices. Okay? Yes. Okay, you're thinking too much. Right? Can I say you're just thinking too much? All right, lads. I'm pretty good at maths because I don't think as much as you guys do. You might think the opposite, but it's not the way. What I see is I see a division sign. I go, in the same way I know B comes after A in the alphabet. I know when I see a division sign, whichever fraction is behind that division sign, it's getting turned upside down and it's multiplying. End of story. All right. And I'm just going to say 9/7, and then I'm on my jolly way to my A. Not taking too much about it. It means multiply. Yeah. Uh, okay, guys. Really quickly. Now, guys, really quickly. These ones here, right? You might think these are pure rocket science. They're not. So I'll show you an example, all right? They look crazy, but they're not. Okay, so look at this one. Does everybody see question 4? Okay. Now, you probably think this is going to take me all day. Not a chance. Be through it in a minute. Glad you look. Step 1. Is it fully factorized? No. That's fully factorized. Now, I'll just get this really quickly. X plus 2, x minus 1. The second batch, x plus 3, x minus 1. Everybody clearly sees the multiplication sign? Okay. And that's 2 times what? X plus 3. And then on the bottom, 4 bracket, x minus 1. Now here's the deal. Because everything's being multiplied, anything on the bottom can interact with anything on the top. So what can I get rid of? What about the 2 and the 4? What's 2 over 4? Okay. What's my answer? What are the only 2 parts unaffected? And the x minus 1? But what else is beside the x minus 1? A 2, yeah. You don't need a 1. But if you really want, it's there. But you don't need to put it in. Okay, still have 2 minutes. So I'm going to load this up later for you to watch again. And I'm also going to load up another video onto, yeah, of course, number 9. Lads, you just be slightly patient with me. It's a long course and it's just nice to try and get these done as best we can. Now, gents. All right. What did I say earlier about the divide sign? Okay. Now, if you don't mind, I'm going to be slightly lazy here, right? Everybody see the 2s? I'm going to flip it upside down like you asked, but I'm going to take the 2 out at the same time. Is that okay? Does everybody still see it's the same thing? Okay. Difference of 2 squares, that's now on the bottom. The 9x squared minus 16 is on the bottom. But that is the difference of 2 squares all day long. It's 3x squared minus 4 squared. And what's that turn into? Just leave me be for a second. Okay, excellent, all right? Now, likewise, on this other one, it needs a bit of prep work as well. Okay? This one I'm going to have to take out 2. All right? Your homework will be on tomorrow's work will be on Google Classrooms. It's this type of stuff. All right, you can go. I'll finish off on my own and then. Okay, lads. So I'm just going to continue working on this. All right, going to take out 2 and get 3x squared minus 10x plus 8. All right, and on the bottom one, I notice they're all divisible by 4. So I'm going to take out 4. I'm going to be left with x squared minus 4x plus 4. All right. Now, when you're looking at all these, none of these are fully factorized yet. All right. So I'm going to start off with this one here. I'm going to factorize this one. And when I factorize that one, it's going to be x minus 2, x minus 2. Right, so I'm going to factorize that one first. So easy marks on the board. sorry about that, x minus 2, x minus 2. So I'm going to slot that up here, right? Now, the next one is this one here, x squared plus x minus 6. And you factorize that one, it's going to be x plus 3 and x minus 2. Right, so once again, I'm just going to get rid of that. I'm going to put up me x plus 3 and x minus 2. Now the next one, 3 times a, 24. Have to make minus 10 out of it, which is going to be minus 6 and minus 4. Okay, and when I do that, what I'm going to get is 3x squared minus 6x minus 4x plus a. Factorize them both. 3x into x minus 2 minus 4 into x minus 2. Okay, and then we're going to get 3x minus 4 and x minus 2. Okay, I'm going to rub this one out. What I'm going to do is I'm going to bring my answer of the factorized version back up into it. Now all of a sudden, I'm going to start cancelling stuff like it's going out of fashion, to be honest. X minus 2 cancels x minus 2. X plus 3, this x minus 2 will cancel with this x minus 2. This 3x minus 4 will cancel with that 3x minus 4. 2 multiplied by 2 on top. See the two 2's I'm highlighting here? 2 then multiplied to give it 4. But then 4 divided by 4 cancels. And I think all I'm going to be left with is x plus 3 on top and 3x plus 4 on the bottom. Okay, so I'm not in tomorrow. So I'm going to, this is questions 9, 4, just 4 and 9 are the only two I did there, and they took a lot of time, unfortunately.